All right, in this video, we're going to talk about something called a tangent of a circle. And the word tangent should be familiar to you because we have used it before in the sense of a trigonometric function, but we are going to talk about it today in terms of a circle. It does derive from trig. So let me just show you real quick why it's called the tangent of the circle. So here is a circle. I'm going to make it have a radius of 1. And a tangent is a line that touches the circle at one point, and this is called the point of tangency. So what I'm going to do is just draw the tangent. So that's it. It never goes inside the circle. It just touches the circle. And I'm going to move this actually over here. And yeah, I'll leave it like that. Okay. When it touches the circle, it will always find a radius to make a 90-degree angle with. Okay. So remember, the radius is 1. This is some unknown measurement out there. I'm just going to put a question mark. And so let's talk about what a tangent is. So if we're going to talk about tangent, let's also talk about sine and cosine. So we're going to use the central angle as the reference angle. So I'm going to call this theta. And I'm going to do the sine of theta and the cosine of theta. So let's call this, I don't know, we'll call this side x. Why don't we call this y? So y is this little piece right here. So the sine of theta is going to be the opposite, which is x over the hypotenuse. Now the hypotenuse is 1 plus y. And the cosine is going to be equal to the adjacent, which is 1, over the hypotenuse, which is 1 plus y. Now, I'm trying to get the tangent, and the tangent of this is going to be x, right? I just said the tangent line is this line that touches the circle one time. So right now, my goal is to only have the variable x using these two terms, okay? So what you'll also learn next year in Algebra 2 is that you can rewrite tangent of theta as sine of theta over cosine of theta. So let's say you had an angle and the angle was, I don't know, the tangent of 25. If you take sine 25 and divide it by cosine 25, it will give you the same decimal as the tangent of 25. So knowing that the tangent is the sine over the cosine, I can take these two fractions and I can put them over each other. Remember, when you're dividing fractions, you're going to multiply by the reciprocal. Nope, that's not the reciprocal. That is 1. And look what happens. This cross simplifies. You're left with x over 1, which is equal to x. And so I've just proven to you that x is the tangent because of this relationship where tangent is the ratio of sine over cosine. So that's why it's called tangent. You don't need to redo this problem ever, but that's why it's called tangent. They didn't just pick their favorite trig function and reuse the word. So essentially, here's what a tangent is. It is a tangent where the point of tangency and the radius are connected, and it makes a 90-degree angle. So it's going to be perpendicular to a radius. Because it's going to be perpendicular, we're also going to be using Pythag a lot. And probably not the hardest part, but the part you really have to think about here is that you do have to add in some of your own numbers, knowing about the properties of a circle. So, for example, in this one, this is where your 90-degree angle is going to be. Since the radius is 10, you're allowed to swing the radius around to here. And now this makes the entire side equal to 36. So it wants to know, is it tangent, or essentially does it satisfy the requirements of the Pythagorean theorem? Or is 10 squared plus 24 squared equal to 36 squared? So that's 100, that's 576. That's 36 squared. I don't have a calculator. $12.96. So this obviously is not equal to $12.96, so this is not tangent. Again, these are the same types of problems. Just remember that you have to take the radius here and put it here. So this would be asking, is 5 squared plus 12 squared equal to 13 squared? It is a Pythagorean triple, so the answer is yes. And then same thing here, this is 12, and you would test out, is 12 squared plus 16 squared equal to 19 squared? Okay. That was just testing if it is tangent. Then there might be other times where it tells you that it's tangent and you're looking for parts of the circle. So in this case, you're looking for the radius. So again, all you're going to do is the Pythagorean theorem. But this is where things get a little bit more, I guess, intense, because you are going to have to do some Algebra 1 stuff with factoring. So here we go. The important thing to know is that where it's touching is where it's 90. If you don't set up your equation correctly, obviously, you're not going to be able to solve it. So r squared plus 77 squared equals, now this whole entire thing is r plus 49. And you're squaring the entire quantity. Pause real quick. In Algebra 1, you should have learned this rule where it said, like, we'll use x plus 6 squared. That is not equal to x squared plus 36. Remember, it's technically x plus 6 times x plus 6, and you are distributing. So x squared plus 6x plus 6x plus 36, or x squared plus 12x plus 36. Okay? There was a formula to do this. It was you square the first term, you square the second term, and then because you're going to multiply two of the same terms, you just doubled this number times the variable. Okay, so let's say it was x plus 8 squared, it would be x squared, it would be 64, and then 2 8s is 16x. So we're going to do the same thing with 49, and I know these numbers are going to seem very large, but this is actually a pretty easy problem in the end. So this is r squared. 77 squared is 5929 equals, use the rule, this is r squared, that's 49 times 49, which is 2401. And then 2 49s is 98r. Now, this one works out easy because, look, r squareds on both sides are going to subtract and become 0. These numbers should become pretty small. I'm going to move the 2401 over here and get 3528 equals 98r. And then just divide that by 98. Whoops. What's the answer? 528. 36. So the radius equals 36. Again, this is the same type of problem where it's touching is 90. So this is r squared plus 56 squared equals, this whole thing is r plus 32 squared. So I'll solve this real quick. You can check your answer when you're done. Okay. The next theorem, it's, I guess, called Theorem 10.2. I'm not ever going to call it Theorem 10.2. I refer to this as the party hat theorem because it looks like a party hat. It essentially says that if you have two tangents, so here's one and here's another, and they are common, they have a common external point. So here's your radius and here's your radius. Obviously the radii are the same. So what it's saying is that if you have this little party hat here, then automatically the sides of the party hat are congruent, or those tangents are congruent. So pretty simple stuff here. If you have two tangents, you just set them equal. So 3x plus 5 would equal 32. 3x's would equal 27. X equals 9. This one, x squared is 49, so x would equal 7. You could have a circle that has multiple tangents on it or multiple party hats. Just be careful that you're looking at the sides that are the same. So in this case, it would be these two. Let me do another line. And these two. So 24, copy paste 24. 20, copy paste is 20. This entire side is 32. If that's 20, that means that this is 12, and so then that's 12. This just went with that problem. Here's another one. Again, these are the same. These are the same. If ST is 5 and QP is 2, find SQ. Well, that's easy because this is 5 and this is 2, and 5 plus 2 is 7. So that's the easier part of the tangents. This part up here is a little bit harder because you do have to multiply your binomials out, but other than that, that's it. And again, this whole thing here, that was just an explanation of where the word tangent was derived from.